Hey guys, welcome to 2.3. 2.3, we're rolling now. I like these type of problems. So again, if I go too quick, if I'm moving too quickly, then please just say, hey, you're moving too quickly and slow down and I can do another video so that I'm more clear and move through the problems a little bit slower. You should read pages 54 through 57. There's lots of examples there for you to read, and it kind of talks about what order you go in solving for an unknown variable. And it starts kind of small, and we did that in the last two lessons. We used addition and then we used multiplication. So we were using the inverse. Now we're throwing in some problems that there's more steps. There's extra numbers. There's more things that we need to take care of before we can isolate the unknown variable by itself. There's obviously several different examples here that you can look at, and we'll kind of walk through each one. There's a chart that I want you to pay special attention to at the bottom of page 54. It says solving a linear equation in one variable. Step number one is simplify both sides. So that just means if there's a bunch of junk going on, there's some parentheses, there's some work to be done, we must clean it up. We need to do both sides first. Like get both sides of the equal sign cleaned up first. Then it says, number two, isolate the variable term using the addition property of inequality. And number three says, isolate the variable itself using the multiplication property of inequality. That just means that we really want to get the unknown by itself. We want to get x equals blah, 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 or z equals blah, 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 blah. We want to get that unknown all by itself. That's what it means by isolate. And the way that you isolate is with the inverse operation. So if it's a plus, then you're going to use subtraction. If it's a multiplication, you'll use division. Those are inverse operations of each other. And then, of course, it says check the solution back with the original equation to ensure your accuracy, to make sure, basically, that you did your math correct. So I'm going to go ahead and start with number one, and I'll work a couple of problems for you in this lesson so that you can sort of make sure you're moving with me along the way. And then we'll talk about the second idea that's expressed in this lesson when you're reading through. And basically, it just says that there's a difference between conditional contradiction and identity equations. And all of them that you're doing in 1 through 36, they're all conditional. And what that means is that you're going to end up with x equals something. And then that basically means that that equation is true under the condition that x equals that certain number. So that's why it's considered a conditional equation. So everything that you do for 1 through 36 is a conditional equation. Let me go ahead and do number one for you. We have 12 equals 2x plus 4x. Now, first off, like I did in one of the other problems, 2.1 or 2.2, I forget, I just flipped both of these because I am much more comfortable having my unknowns on the left-hand side of my problem and having everything else to the right-hand side. That makes me happy. So I'm going to just flip it to begin with. Now, I want to solve for x. So what I want to do here is combine my x terms. I have a 2x plus 4x. So I can literally just add them together to end up with 6x. This basically says 2 times something plus 4 times the same something. And so I can take my 2 and my 4 and add them together. I'm still going to have the total amounts of my something, which is 6 times the something, which happens to be x. So I have 6x. So this says right now 6 times x equals 12. And we know that the inverse of times x is divided by x. And the easiest way to show it is like this. These are going to cancel. On the left-hand side, I'm going to have x. And this right here literally says 12 divided by 6. And we know that 12 divided by 6 is 2. So we understand that x in this equation we believe to be 2. Now I'm going to have to check it, okay? So I'm going to put 12 equals 2x plus 4x. I still really would prefer my 2x and my 4x on the left-hand side and my 12 on the other. But because I don't have to write it down a zillion times in this example, I'm just going to leave it as it is. And I am going to substitute my 2 in for all these x's. So I'm going to have 2 times 2. That's a smush 2. Plus 4 times 2. And that's an ugly parentheses, but you're with me. 12 equals 2 times 2 is 4. Plus, don't forget your order of operations. It's still important. The multiplication has to be done first. 4 times 2 is 8. And now I can do the addition. 4 plus 8 is indeed 12, and so I know it's true. So when you're giving me your answer, you're going to give me x equals 2, and I have to see the checked version. So that's how you solve each of these equations. That's just the first one. I'm going to go ahead and do problem number 2 for you as well, which is kind of why we're all here together. Let's do number 2 because 2 has a couple of extra steps. I hate these ones that are written backwards. 2x plus 7. So just because I like to flip it, I'm going to say 2x plus 7 equals 15. Now you'll notice that I have a 2x and a plus 7. Okay, 2x and plus 7 are not like terms. I cannot combine them. I can't say 9x because 7 isn't multiplied by x. They're not like terms. So my goal is to get this plus 7 out of the way. I'm going to get rid of plus 7. There's an example like this. 2.3b. It's kind of like this one. I want to get this 7 out of my way. So I know that the opposite of plus 7 is minus 7, and I also know what I do to one side, I must do to the other. Oh, I totally felt that sneeze coming on. I'm not redoing this video because I sneezed. I apologize. A sneeze is a sneeze. Okay, plus 7 and minus 7, they just cancel. That leaves us with 2x equals 15 minus 7 is 8. Okay, so 15 minus 7 is 8. 2x equals 8. This says 2 times x equals 8. We know the opposite of times is multiply, so I'm going to say 2x divided by 2. We know the opposite of times is divide. That's what I should have said. The sneeze is still rattling around in my head. So I end up with x equals 4 because remember this says 8 divided by 2, and that is 4. So I'm going to have to check it. So I'll come back up here and I'll just put 15 equals 2x plus 7. And this says 2 times x. And we know x is 4, or at least that's what we believe it to be. So I'm going to say 2 times 4 plus 7. 15 equals, multiplication comes before addition. So I have 8 plus 7, and 15 equals 15. Okay, I want you to pay really close attention to the problems that I assign for you. I must have both of these in my final answer, okay? Pay really close attention to the problems that I assign for you because I likely will not make you do all 36. So definitely check the instructions there and solve the ones that you need to solve. I am going to turn you loose all the way down through number 16. I'm going to solve number 16 for you. So go ahead and solve all of them that I assigned for you from 1 until 15. And then I'm going to jump back and I'll meet you at 16. Okay, so I'm back at problem number 16, and the problem looks like this. 2x minus x minus 3x minus another x equals a negative 6. I'm going to make sure I got all that. 2x minus x minus 3x minus x equals negative 6. Okay, so this looks a little scary and kind of complicated, but it really isn't. I just have to combine this positive 2 with a negative 1x, a negative 3x, and another negative 1x. If you wanted to combine your negatives here, you can. It really doesn't matter. It's basically like saying positive 2 minus 1 and 3 is 4, and another one is 5. So it's like a negative 5 here, and you would end up with a negative 3 overall. So when I combine these, I'm going to combine for a negative 3x equals negative 6. I have negative 3 times x. I want to divide by a negative 3. These are going to cancel, and this is going to give me an x equals 2. Why does it give me an x equals 2? Well, negative 6 divided by negative 3. We know a negative divided by a negative is positive. 6 divided by 3 is 2. So we end up with x equals 2 for number 16. And then I need to check it, of course. And so I'm going to, I can put my 2 back in for all these x's. and I'm going to let you do the check work yourself on this one. But x equals 2 is correct. So when you check it, you'll end up with a -6 equals a -6. But you show me the work on that if number 16 is assigned. If not, then you'll know how to solve those problems. You can go ahead and pause me now and then meet me back for problem number 31. So pause me, work problems, meet me back for 31. Okay, I'm back here for 31, and I want to show you 31. I want to work it out because you do need to use the distributive property, and I just wanted to be able to remind you. So your problem says 2 times the quantity of x plus 1 minus x plus 4 equals 2 minus 3 plus 4. Let me just double check, make sure I copied everything down correctly. Okay, so please excuse my dear, and Sally says I need to do parentheses first. So cool, I'm just going to combine x plus 1 and x plus 4. Oh, wait, I can't. I can't combine x plus 1 and x plus 4 because I don't know what x is. So remember, the way we jailbreak or we get rid of our parentheses when we can't do anything else to them is multiply by this number outside, and we use the distributive property to do so. So this first one, 2 times x is 2x. And then 2 times a positive 1 is positive 2. Now on the next one, when we're trying to jailbreak it, what's interesting here is we have a -1 out in front. So we have to make sure we remember that's an assumed -1. And -1 times x is a -1x. And then a -1 times a positive 4 is a -4. And then I have 2 minus 3 plus 4 still to go. So on this first half right here, I need to combine my like terms. So I have a 2x and a -1x. So 2x, positive 2, minus 1x is just going to leave me with x. And then the other like terms that I have is a positive 2 and a -4. Well, 2 plus a -4 is a -2. So I have x minus 2 on the left side, and I can actually go ahead and do this if I want to. 2 minus 3 is going to be a -1. Plus 4 is going to end up being a positive 3. So hopefully you're with me on that one. Now this says x minus 2 equals 3, and I want to do the inverse. I want to get rid of the -2. So in order to do that, I need to add 2. And if I add 2 to one side, I must add 2 to the other side. And that's going to give me an x equals 5 for 31. And so 31 is going to end up being x equals 5. And that is true. I'm going to leave you to check it by yourself. You should end up with 3 equals 3 to prove this to be true. I'm going to let you check it by yourself, though. But that is how you're going to want to work 31 through 36. You're going to have to use the distributive property. And I will tell you where everyone messes up. Seriously, the big mess up is right here. Because you have to remember that there's this -1 and you have to distribute this out. You can't just say minus and then just start throwing in minus x plus 4 because this is not a plus 4. Okay, it's a -4 because you had to distribute the -1 times a positive 4, which is a -4. So that is where almost everyone makes their mistakes. Please be careful not to make that mistake. Go ahead and finish all the way through until the end of 36, and I'll meet you back for 37. Okay, so I'm back for 37. 37, here are the directions, okay? It says identify each equation as conditional, which is exactly what we just ended up doing. So you're going to end up with like an x equals whatever x equals for that problem, okay? Those are all conditional. So if you look at the problem and you solve through and it's x equals something, totally conditional problem, not a big deal. Then it says contradiction or identity. Now, an identity, I'm skipping to identity. Identity is the first one that they introduced back on page 57. So 57, 2.3. When you're solving and your x's vanish, Okay, when your x's like literally just go away as you're doing the math and you only end up with like something equals something and it's the same thing, then that's called an identity equation. So if that happens to you, then that's called an identity equation and you're just going to say that it's an identity and you're going to just say it's an infinite number of solutions. Okay, it's just an identity. You can just write identity as the answer. Easy peasy. But what if, like in example 2.3g, your x's go away and then you end up with something that's not accurate, like 6 equals 5 is the example on page 57. If that indeed happens to you, then it's considered a no solution. The answer to that is no solution. That means nothing's going to work. And the type of problem that is a contradiction. So for 37 through 45, they just want you to work it and then just say what it is. So I'm going to work number 37, and it's 4 times the quantity of x minus 2 equals 2 times the quantity of x minus 2. All right, who knew? They're the same. So, right, I have to do the parentheses, right? So I need to just be able to slim this on down and take care of this parentheses, except for that I cannot do anything with it because I can't take away 2 from x when I don't know what x is. So how do you jailbreak it? Well, you use that fancy smancy distributive property. 4 times x is 4x, and positive 4 times a negative 2 is a negative 8. Gonna have to also use fancy smancy distributive property over here too. 2 times x is 2x, and positive 2 times a negative 2 is a negative 4. Okay, so now I need to get my x's all on the same side, and hopefully you're a genius at this. I didn't cover it too much in the first half of the lesson, so hopefully you didn't have a problem with it. I need to get this x over on this side. So this right now is a positive 2x, so I'm going to say minus 2x minus 2x to get my x's on the same side. 4x minus 2x is just 2x. Go ahead and copy down my minus 8 and go ahead and copy down my negative 4. Okay, so again, I'm going to get x's by itself. So here, the opposite of minus 8 is plus 8. Plus 8. Okay, so this is going to cancel. It's going to leave me with 2x equals a negative 4 and a positive 8 is a positive 4. Hopefully you're with me on that one by now. Okay, so I have a 2 times x equals 4, and the way that we undo times is by divided by. So I'm going to cancel this out. I have an x equals, and remember this literally says 4 divided by 2 equals 2. So I get an x equals something. Boom, x equals something. That's just a conditional equation. It's the same thing that I've been doing. So literally, you're just going to write the word conditional. CONDITIONAL. Okay, now listen. If you want me to give you any kind of credit at all, partial credit I'm speaking, if you wrote down the wrong thing and you did not show me all this math, I cannot give you any partial credit. If you wrote down identity and it's actually a conditional, I just have to mark it wrong. But if you show me some math and I can see maybe where you erred, like maybe you didn't know that 4 divided by 2 was 2, and maybe you put a 4 here or something, I don't know, and you somehow messed yourself up just by doing the math, I can give you some partial credit. So do your math, show me your leveling math, show me how organized you can keep your leveling math, and then write what it is. Now, just for cheating purposes, okay, I want to be able to show you something that is not a conditional. So I'm going to just jump right now with you to problem 39. I'm probably going to make you do 38, so, don't get too overly excited, but I just want to show you 39. So 39 is 3 times 2x plus 8 equals 6x plus 18. Okay, I have to do parentheses, but I can't combine unlike terms, so I'm going to have to jailbreak by using the distributive property. 3 times 2x is 6x, and 3 times 8 is what, 24? Yeah, it is. Way to go, brain. Equals 6x plus 18. Okay, I want to get my x's on the same side, right? So I'm going to take this one and put it over here. Right now, so it's positive 6x, so I'm going to have to say minus 6x, minus 6x. Okay, boom, those cancel. Okay, boom, those cancel. So that leaves me with a 24 equals 18. Up, not true. Boom. So the way I'm going to show it is I'm going to put this slash through the equals. And this is what tells me this is not true. 24 does not equal 18. So I'm going to show that, and then my answer is going to be a contradiction. So literally what I'm looking for is the word contradiction and and this. Okay, I need to see this and I need to see this, and then I'll know that you know how to do 37 through 45. If you have any questions, ask me. Now, just looking really quick at the review, I'm not going to make you do that crazy chart from 1 through 4. I don't like it, and I think it's kind of confusing. So you will not have to do that in your review. You're only going to have 5, 6, 9, and 10, all of which I think that you can do by yourself. So happy trails. Good luck. I know you can do 2.3. Definitely check and only do the ones that I assign you, because I probably will not assign all of them to you. Email if you have questions. Goodbye.